Well, I confess the one part of the week I've been looking forward to all week on this show has arrived, and that's the chance to say good morning to the Naked Scientist, Dr. Chris Smith, joining us on the line from Cambridge in the UK. And delighted to have you with us as always, Chris.
Oh, hello,
Welcome.
Pippa.
While we wait for those first calls to come through, Chris, there's quite an interesting and exciting anniversary or centenary coming up in a couple of days' time about a very particular photograph with a special history. Tell us more.
Yes, indeed. So on the 29th of May, it will be 100 years since Arthur Eddington, who was the Cambridge Plumian professor at the time, journeyed to West Africa and also detailed another team to go to Peru, to a part of South America, and they took a very famous photograph, each of those groups, of a total eclipse. The reason they did that is because Einstein in 1915 had put forward the latest in his iterations of the theory of relativity, and he'd finished that theory, but what remained was some incontrovertible proof that he was right, because obviously the world was very much divided. On the one hand, everyone believed that Newton's 300-year-old maths was absolutely de rigueur, that was the way it was. Then there was this upstart called Einstein, who not only was he an upstart, he was also the enemy, because Britain and Germany, of course, were at war at that time in World War One. Yeah. So do you believe his science? The way to prove it was to take these pictures of a total eclipse, because Einstein's theory predicted that if you looked at stars that were very close, or the star light coming to us, passing very close to massive bodies like our own star, the Sun, then there should be a warping of space-time by the mass of that big object, and that warping of space-time should bend the light from the stars, giving the impression that they're in a slightly different position than the one they're really in. But in order to see stars which are literally just grazing the edge of the Sun, it's really difficult, because the light from them compared to the light from the star means that one totally bleaches out the other. But if you have an eclipse, then you can see those stars, and that's what Eddington's experiment did. They were able to take the photographs, and they showed that when you compare the position of the stars compared to where they appeared to be when seen in that position during that eclipse, they were off by about 1 3/4 times the width of a star as it appears in the night sky anyway. And that was enough to show that Einstein was right, and actually the space around the star is being bent to make objects that are in the distance appear in a different place. So it is famously 100 years on the 29th of May since that experiment took place, and the world of physics has never been the same since.
Absolutely fascinating. Thanks for flagging it for us. Right, we've got callers lining up already, so let's go straight to the lines, and we start with George in Somerset West. Good morning to you, George.
Hi, Pippa. I was watching this food program on Netflix or something, and they spoke about drying things in general to intensify the flavor, food things, Mm-hmm. And one of the things that they did was green beans, which they string up on a string and they hang it up, and then they dry them, and then they cook them, and then they're a lot more flavorful. So I thought, well, I've got green beans, I'll do that. And so I took half of the beans I had, I strung up just like they did and hung it in the pantry, and the rest I put in a open container in the fridge and dried them in the fridge. It's a self-defrosting fridge, so it dries that way. And the thing is, the two taste completely differently.
Really?
The one that was air-dried has no taste at all, and the one that was dried in the fridge is really nice. Why is that?
That's fascinating. Chris, have you got an answer?
Well, George, I've never tried doing the experiment, but congratulations to you for actually trying to do the controlled experiment where you compared two different conditions. The answer to this is, I don't know for sure, but obviously the treatment that the two are receiving is quite different, because when you've got beans at high temperature in room temperature, they're going to experience a certainly different biochemical milieu compared to the beans that are in the fridge, because when you drop the temperature, you drop the rate at which chemical reactions occur. And there's actually a sort of general rule in chemistry, which is if you double the temperature, you double the rate. And the rate of a chemical reaction. So the chemical reactions which are going on in the beans are going to be lower in the fridge. And the reason we put food in the fridge or even in the freezer is that everything degrades. And it degrades because the chemicals which are in the foods already are released when you cut the food off the plant or you cut the leaves or whatever. You're damaging the tissue and you're releasing those chemicals which are naturally in the plant. They have a degradative effect. you also have microorganisms, including fungi and bacteria, which grow on and in some types of food. And they also depend on their metabolism to degrade food. The chemical reactions that sustain all of the above will slow down at lower temperature. Therefore, the beans are going to keep much better in the fridge compared with the beans which are going to be dried in the air, which are going to have experienced warmer temperatures, and therefore they will have had more degradation because the kinds of processes that degrade them and eat away at all the flavoursome molecules in them are going to be going faster in the room temperature. The ultimate outcome may be the same, that dry air in the fridge and dry air in a room is going to dry the food out, but the experience it has on the way to getting dry is going to be quite different for the two things, and I suspect that's at the heart of this.
Okay. Now, an interesting follow-on comment from Ansel in Paarl saying this is why chilled red wine also tastes much better. Would the same apply to alcohol?
Well, the other thing to bear in mind with any kind of food stuff, especially things like alcohol, where most of the experience from wine and beer, when we put them into our mouth and we wash them around the mouth and we get what's the palate, and we also describe what we call on the nose, these things are very rich in volatile chemicals. These are small molecules which, when you put them in a warm mouth, they evaporate off and they go up the back of your nose and stimulate your nose system. So they stimulate your olfactory system. So most of what we call taste, it's not exclusively, but most of what we call taste is actually smell. And so when you put wine in your mouth, actually you're smelling it and calling that taste. So cooling down wines, some wines taste much better colder, some taste better warmer, and the reason is that the spectrum of chemicals they contain tend to perform better, are preserved better, and the chemical reactions that make those things tend to accelerate or decelerate accordingly, corresponding to what you want, obviously, at different temperatures. So therefore, that's why we guide people to take wines or store wines at certain temperatures and to drink them at certain temperatures, because that profile of chemicals that gives you the initial hit of flavour is going to be presented slightly differently to your smell system at different temperatures, because some things are more volatile than others. Some molecules will evaporate up into your nose faster than others, and the flavour that you get is going to be driven by the order and the concentration of those things hitting the back of your nose, and that's going to occur at different temperatures, which is why some wines appear to taste better when they're cooler, some when they're warmer.
George, thanks for a very interesting question. Appreciate your call. We go next to David on the line from Gordons Bay. Good morning, David.
Good morning. How do you do?
Well, yourself, how are you having your day? How's your day going so far?
Good, thanks. It's a bit too early to tell, but hopefully.
Good. What's your question for Chris?
Considering that our bodies are made up mostly of water and, well, the rest of all the mammals on the planet, I suppose, what effect, if any, does the full moon have on us?
The answer
What
is
effect does the full moon have?
probably
Yeah.
very little. There have been a number of studies looking at this, because there's this word lunacy, and there was this idea that people go mad on the full moon. Lunar in Latin is moon, and so there was this idea that human behaviour would change with the moon. There's myths and legends about werewolves, for example, coming out around the full moon. So there's a lot of folklore, but is there actually any evidence? The evidence is probably very, very slight. There is some, and in fact there was some that occurred serendipitously. There was a group in Switzerland who did a sleep study. They're actually looking at people who they brought into the lab, and you put people in ideal situation for sleeping. So you remove any other cues like light and dark and all this kind of thing, and you make various measures of how well they sleep, how long they sleep, etc. And they happened to have this enormous data set, which was recorded years previously, of how subjects performed when they were in this lab. Now, because they knew when the subjects had come into the lab and they knew what their sleep pattern had been like in the lab, someone had the bright idea of saying, well, hang on a minute, let's take that data, which we know all the dates, so we know what the moon was doing at the time. Was there any influence? And when they looked, they found that there was evidence that people who came into the sleep lab around the time of the full moon had different sleep patterns compared to people who did the studies not around the time of the full moon. So there does appear to be an impact. They don't know why. It might be something to do with the fact that it's brighter at night, so people stay up a bit later, so they adjust their sleep pattern. There may be something else going on, but we don't have any evidence that that translates into gross behavioural changes, although if you're not sleeping as well, then your behaviour might be a bit different the next day. So there might be something in this, but it's going to be a fairly trivial impact. It's not going to be anyone turning into a werewolf anytime soon.
Thank goodness for that. Okay. Good day to you further, David. A question on the WhatsApp line from Ivan, who wants to know, why is it then when watching a film with cars moving clockwise, the wheels seem to look like they're turning anti-clockwise?
Yeah, hi, Ivan. This is a classic one, and very often we would see this in old westerns and things. The person would pull away with their cart, and the wheels would appear to accelerate in the right direction to start with, and then suddenly they start to go backwards. And it's all to do with strobing. What do I mean by that? Well, when you have a strobe light, it flicks on and off very quickly. So you could take a picture of something, and then you turn the light off, turn it back on again, and you get another snapshot. Turn the light off, turn it on again, you get another snapshot. And if the object is moving, you see the object moving in a series of jerky snapshots. Now, if you have the camera pointing at a wheel, because these old-fashioned cameras were a bit slower than the ones we take today, but they're taking a certain number of frames or pictures per second of the wheel. So it's a bit like a strobe light illuminating the wheel, because you're getting a snapshot, a snapshot, a snapshot. The wheel moves round a bit, and you take the next picture, and you've seen it's gone from A to B, let's call it, position A to position B. You then take another picture and you see B go to C. Well, you might end up with a position where the wheel ends up going sufficiently fast that actually it goes all the way round to where it started, and then round a bit more, and then round a bit more, and around a bit more, and eventually it gets all the way round and almost back to the start again before the next picture comes, which gives you the impression as the viewer that actually it's gone backwards a bit, not forwards a bit. And then as the wheel goes even faster, it happens a bit more and a bit more. So it looks like the wheel reverses because it's gone all the way round to where it was and almost back to where it was each time. But then once it gets to a certain speed, it's going so fast that you can't see it anymore. So that's why. It's because of an illusion created by the stroboscopic effect of the camera that's taking the pictures at a certain rate.
Ivan, thanks so much for your question. Let's go back to the lines. Roberta in Stellenbosch has a question regarding veganism. Roberta, good morning.
Good morning there. How are you?
Well, thanks. And yourself?
Great there. Just from my side, I recently, about 2 months ago, I watched the Netflix series What the Hell, and it literally changed my whole perspective of meat eating and the things we do eat. And since then, I've been vegan for about 2 months now, since I watched the show. And basically, my question is, like, what the show explained was how humans, from our teeth, how our teeth are formed and our intestines, basically we were meant to actually eat plants. And then gradually over the years, as the years went on, our canines started getting sharper, our intestines started developing differently. That's from what I think so. And from all the meat we've been eating. So basically, I wanted to ask, were we born to eat plants or meat?
Well, if you think about it, historically, we would have been a creature that came out of the sea, crawled onto the land, and then evolved into all of the creatures that you see around you today. And they include herbivores and omnivores and carnivores. So we're all related because our life history goes back millions to billions of years. But our particular lineage, if you look at the other animals in our lineage, they eat meat too. And meat is a prized food item because it contains a lot of micronutrients that are very essential to good health. These include things like iron, which obviously you need that to run various chemical reactions in your bodies and make blood, lots of B vitamins and other things that are harder to find from plants. So it does appear that actually we have evolved to eat a mixed diet, not just exclusively one kind of diet. People who were exclusively carnivores would not be healthy. People who are exclusively eating certain types of plants on a subsistence diet, they get unhealthy too. We do need to balance what we take. And also, you need to make sure that you don't have any gaps in your diet, because it's very easy when you adopt a new kind of diet. There's several things you may not be prepared for. One is that the microbiome, the bugs that live in you, are adapted to what you have been eating. They're not adapted to what you're now eating. So that takes time for them to shift around and to maximize the energy that can be derived from the food you're eating and for your intestines to settle down. You also need to make sure that by removing certain things that you were eating a lot of before and probably relying on to get micronutrients, that you put back those things that you're now not getting. And iron is a classic one. And many people who switch into vegetarian and vegan diets can make a mistake and they don't get enough iron in their diet, or iron that's available to their body to use, and they can end up anemic and very tired. So just make sure that you're very careful with what you eat and how you eat it to make sure you stay healthy.
As a matter of interest, Chris, how long does that adjustment period take? Does it depend on what you were eating before and what you've switched to?
It takes a while. There's been a number of studies looking not just at people just shifting the type of diet they eat, but people, for instance, shifting towards losing weight. because people have been very interested in the role that the microbiome may play in weight gain and weight loss. And the evidence is that as you gain weight, you shift your microbiome to favour a weight gain promoting bacterial makeup in your intestines. If you then shed a lot of weight, you can shift that back towards the microbiome which is normal for a slimmer person. But it takes about 6 months before those effects become locked in. So if you don't stick with your healthy eating for at least 6 months, your microbiome very quickly relapses back to type, and you very quickly regain the weight you've lost, and you tend to rebound and gain even more weight. Whereas if you can sustain the healthy eating, the dietary adjustment, the lifestyle adjustment for at least 6 months, then you can actually show that the populations and the spectrum of microbes has adjusted, and it almost becomes locked in. So if you go on a diet and you do lose some weight, you've got to be in it for the long term. Quick fixes don't work because your microbiome will very quickly relapse to a type that promotes weight gain again.
Okay, thanks, Roberta, for your call. On the SMS line, Louis asking whether it's possible to produce electricity in a vacuum.
No reason why not. But why would you want to? I mean, the easiest way I could think about producing electricity in a vacuum would be you could use the electromagnetic effect, because magnetism and the electromagnetic waves that we are accustomed to can propagate through a vacuum. That's exactly what's happening in space, for example. So the sun is putting out light, which is an electromagnetic wave, and solar panels on the International Space Station, they are seeing that electromagnetic wave and converting it into electricity. That's the production of electricity in a vacuum.
Okay. Our next question is an interesting one on Twitter. Werner asking if you can please explain the Dunning-Kruger effect.
No, I need to know what that is. So if someone can tell me what that is, then I'd be happy to have a go.
All right, we maybe put that one to you as some homework to follow up for next time. In the
I'm
meantime,
writing that
let's
down.
go back. Okay, Dunning-Kruger, Dunning dash Kruger. I'll do a quick Google while you answer the next question and see if we can get a little bit more light on that one. In the meantime, Andrea, sorry to hear this, Andrea. She says, I've got a cold. I've been taking vitamin C tablets to try and speed up my recovery. And a friend says I am wasting my time. Is she right?
Yeah, sorry, Andrea. It's not worth doing. The only evidence in support of vitamin C was done in Norwegian cross-country skiers, I think. In other words, people doing extreme exercise, and they found that taking vitamins C and other supplements, maybe a bit of zinc, helped to reduce the likelihood of catching something in the first place and possibly shortened the duration. But I don't think there's very good compelling evidence that in a person who's eating a healthy diet and is vitamin C replete already, that taking mega doses of vitamin C makes really any difference. The way you recover from a cold, colds are caused by viruses. Viruses are parasites, which are basically genetic parasites. They hijack your cells and turn them into virus factories. You need your immune system to deal with that, and specifically the CD8 cells in your immune system that kill virally infected cells. That means you've got to make lots and lots of cells very quickly, and the way you do that is making sure that you are not putting other demands on your body. So you've got to take it a bit easy when you've got any kind of infection, and make sure you stay well fed and well hydrated. I know they say feed a cold and starve a fever. Well, colds do give you a fever sometimes. There's no evidence whatsoever behind that. It's just an old wives' tale. So eat well, drink well, rest well, and that's the fastest way to recover. Vitamin C, probably, unless you're vitamin C deficient already, is not going to really help very much.
Okay, Andrea, so eat, drink and rest well. Listen to Cape Talk while you're at it, and I hope you feel better soon. So I did a quick Google while you were answering that question, and I see from Wikipedia that the Dunning-Kruger effect in the field of psychology is a cognitive bias in which people mistakenly assess their cognitive ability as being greater than it actually is. Okay, Chris, maybe one for you to do some research on for next week.
I'll take a look at that. I mean, it's like we had a politician here called Michael Gove, and he was asked when he was commenting on education, he said, I want everyone in school to be above average. Now, clearly he didn't listen in his maths class, did he?
Apparently not. Right, I think we can squeeze in one last question, and it's another health-related one, asking whether 5G networks affect our health.
Well, we don't think so. And the reason or the rationale for thinking this is that these networks, mobile phone communications, for example, are propagated using microwaves. They're the same thing as the thing that cooks your food in your kitchen and propagates your computer network signal around your house. These waves don't have enough energy in them to rip molecules apart. They're not energetic enough to break the bonds between atoms. Chemicals and radiation that does do that, we know does cause cancer and other health effects. So for this reason, we're comfortable that, at the moment at least, with the data we have, there's no evidence linking the microwave signals coming from cell phone towers and similar to bad health. People are doing a huge, great study on this because for the first time in history, really, we've got enormous numbers of mobile phones using this radiation all over the world. And by virtue of the fact that the phone companies know when you're on your phone, we can very well estimate what the exposure of every individual on the planet is. And so for that reason, you can then work out, well, if we know what the exposure is, we should see something called a dose-dependent relationship. And if these things do affect your health, then the more exposed you are, the more ill health effect there should be, the more of these diseases. At the moment, there's no evidence for any kind of rise in disease impact through people using these devices. But people are watching, and we'll find out. It might take years to establish, so we're going to find out.
Chris, always great to have you with us on the show. Thanks so much for joining us, and enjoy the weekend.
It's a pleasure. Thanks, Pippa. Bye-bye.